Hello everyone, and welcome to my video tutorial series here in database management, and welcome to this lesson on Introduction to Database and Design. I want to start out first by talking a little bit about the general term of database, because that's the heart of everything, right? We need to know what a database is, and we've worked with databases all our lives and maybe not have even realized it. And generally when we talk about databases, we're talking about structured data. And this is data that is organized, and it's a collection of this organized data that's put into some type of collection that's logically related and consolidate onto a single system so that we can take that raw data and make it into some useful information, whether to one person or multiple people. The information has to be useful. Data is just that. It's a bunch of facts, but we need to turn that data into information. And a term that we use in databases a lot that you'll hear is metadata. This is information about our data. So I won't go in that very much, but metadata is just simply think about it as data about data. If I have a collection of CDs, some metadata about that is I might have 300 R&B CDs. I might have 72 country CDs. I may have 16 albums by the Beatles. That's just data about my general collection of data. And we can use this metadata to make more informed decisions from our database collection systems to make better business decisions. And I won't get into big data in this lesson, but that's one key part of metadata. In the database world, when it comes to data, redundancy is a bad thing. This is that part in IT where redundancy is not wanted. If we have data that's duplicated over our system, that means there's lots of rooms for us to mistake that data, or if we go to make a change to that data, we have to know all the places that piece of data is located so that all the changes are made correctly. And that's very difficult to do, and that's where human error comes into place, and that's where we make bad decisions because we have bad data. All of our data must be easily readable for and available to our users. If we have lots of data but no one has access to it, what good is that data in helping make that useful information? If you have an address book, such as on your phone, then you've used a database. When you're putting new data in on your phone for a new contact, that's a form. And that form is going to take that raw data that you put in there and make it into useful information. When you need to contact that person, or if you're trying to remember where that person lives or what their email address is, you have it on that contact form. Therefore, that data, those raw facts about that individual, have now become useful information. And that database, that collection of all of those contacts, is now in one place. It's consolidated into a system that is going to provide you that useful information. Well, we need a system to be able to manage all of this data for us. And that's where we get into a database management system. Makes sense, right? And we have different types of database management systems, such as hierarchical databases or relational database management systems. But in the purest form, a database management system is just some piece of software, a software system that we can use to create, maintain, provide access to or deny access to our data and the users of our database, and to be able to provide data security so that our data is not susceptible to intrusions. We want to be able to make sure that we can ensure data integrity, that the data is exactly what it's supposed to be, and reliability are guaranteed. We need to be able to make sure that we can get to that. There are lots of different database systems. I can't cover them all, but the actual program that's used for the database application, this is a program that's going to interact with the database by using different types of requests of programming, such as with SQL statements, to that database management system. And one term that we use a lot when it comes to the database world and structured data are relational databases or relational database management systems. And relational databases were designed to solve the problems that we saw with hierarchical or flat files. we need to be able to have that data that is related to one another. There's certain elements that need to be there, and that's so that our data is structured, so that we can make some sense of the data in relatively simple terms. And part of that structure is with tables. All of our data, even that metadata, that data about data, needs to be stored in repositories such as tables. There need to be names to those. There need to be columns with properties. In that structured organization, we need to be able to see rows that are in these tables. That's where those rows are going to uniquely identify the data in that row that all pertains to one object. All of our tables need to have such things as primary keys that identifies that is unique. That piece of information is unique. Then we need to have relationships between these tables so that we can see that the data in this table and in this other structured table, somehow they're related. So that way we can tie that data together. And when we do this, when we repeat any data, that primary key that says, hey, this is unique information. This is what sets this data in this row apart from this other row, such as with your driver's license number. Your driver's license number is only assigned to you, just like your social security number. So the name, the first name, the last name, that's only going to be tied to that unique number. No one else is going to have that. But if we repeat this information, that unique information, in one of the other tables to create a relationship, that primary key, that unique key, when it's in that other table, it's foreign to that table, so that's why we call it a foreign key. But it is a unique piece of information that creates that relationship to another piece of structured information. So your social security number in one table for, employee information might be tied to a automobile table in another area using your social security number that says, okay, social security number 111223333 belongs to Billy Bob No Name. And then another table, that same social security number is used that relates to that car. Let's say it's a Porsche Carrera, 911 Porsche Carrera. Well, that car is identified to that individual, Billy Bob. That's how we relate the information. We know Billy Bob's name and we know what car Billy Bob has. Going back to the relational database, that relational database is going to match data using common characteristics found within that data set. The resulting group of the data is going to be organized and is much easier for us as users to be able to understand. And that software used to do this grouping, that's our relational database management system, the system we use to manage that relational database, that organized data. So that's where structured versus unstructured sometimes comes in. Structured data, we're able to perform data analytics much easier because the information is organized and there are rules in place to make sure that that data stays organized. And we use SQL, structured query language, to be able to retrieve and work with the data that's assigned and organized within these tables. With our structured data, our data consistency is there. We have much more information from data. We can ensure our data integrity, security, and maintenance. With unstructured data, which a lot of data is unstructured, this is where we get into the realm of big data. Unstructured data is going to be more difficult to work with. It's more rich data that contains a lot of information or a lot of raw data. That makes it much more difficult to represent in a neat and orderly fashion. So if you hear those terms, you should be able to distinguish between structured and unstructured. As I mentioned earlier, there are lots of different database companies. And specifically, as I'm talking here about relational database management systems, there are several to choose from. Oracle has several. Microsoft offers lots of different options. They have Microsoft Access as a very cheap, easy user software. They also offer SQL Server, which is you're going to find in a lot of places being used. IBM offers its own relational type of database called DB2. There's open source options out there for free as well, such as MySQL and PostgreSQL. Behind the scenes, transaction engines need to be there. interface drivers, storage engines. SQL is always in the background being used. It is the most widely used query language out there. Here's an example. I wanted to show you not only just some basic information, but give you an idea of what SQL or structured query language looks like. This is how I'm not going to go into it in depth, but this is how we can create data, manipulate data, define the data. And you see here I've got a couple tables listed here. We have a faculty table and department table. And then within those tables, we have a couple columns. We have the name and department columns, and records or rows that we put in this table. We're going to have a name listed on in one cell, and then the next we're going to have information under the department column for what department they're in. Same thing with the department table. You can see we have a department code and we have the chair. So this is information we know what kind of data it is. This is very simple, so we're not defining the different data types here. But if I want to get information from tables, I can write queries. It says select, and I want to select the chairs. I want all the chair information. From where? From both the faculty and the department tables that meet what conditions? That's where the where clause comes from. Where the faculty name or the name column from the faculty table, we use that dot notation there, faculty dot name, that says where the data is and what data I want. And I want anywhere in the name column of the faculty table that's equal to Billy Bob some name. And I want it to meet another criteria that in the same table, faculty, I only want the rows or the results to return where the person's name is Billy Bob some name and that they are in the department from either table. We're doing a join here where we're saying give me all the information in both the faculty and the department table because those are equal. We're saying that based on that primary and foreign key relationship I talked about earlier, department is a primary key in one table, it's a foreign key in the other table, but because the data is exactly the same, we have a relationship. They're related. The name of the person in faculty will have an associated department in the department table, and they need to match up. Now I can also define information with structured query language. You can see I've got a DDL here, data definition language. Here I'm going to create a table. And I won't go through all the code here, but that's what I'm doing. I'm defining an element with SQL. On the right side here, I've got data manipulation language example here, DML. I'm going to query, and I'm going to select the information. I'm going to update and set a value equal to a new value where it meets a certain condition. So I'm going to manipulate the data that already exists in a table that I deem that I want to make changes to. And I'm going to set some value equal to a value where it meets a condition that I have established. So if I wanted to change, I misspelled some name, it was supposed to have been no name, I can update the name field and set the value Billy Bob some name equal to Billy Bob no name, where name equals Billy Bob some name. Every instance of Billy Bob some name will be changed to Billy Bob no name as long as it meets my criteria. So that's a little bit about structured query language. Won't go into that a lot. Here's an example, a visual representation of some tables and some of those areas I've talked about. If you look, we have the table names. Those are at the very top. They're always capitalized. So if you were doing an ERD, an entity relationship diagram, when you're in that stage of creating your database, not just typing away and making your tables, you're actually doing the planning, always make sure your table names are capitalized. Once again, the table is where it's going to store the data. We have our attributes or our columns, such as book ID and book title here on the left, and chapter ID and book ID in the chapter table. I have a PK representing my book ID because it's a unique field. No two rows in that book table will have the same book ID. It is a unique identifier, this primary key. And I'm going to use that in the chapter table, but because it is not native to the chapter table, it is a foreign key. A foreign key is just a category or a column that was a primary key in another table. That's it. And then we could go in and we could go into data definitions, but we won't go that far in depth right now. Just know that we need to make sure our raw data facts need to make sense, need to be organized. And then here's how we create a relational database, because we're relating information from one table into another. Now, there are different classifications of our database management systems. As you can see here, I have different criteria listed as how our database management system might be classified, such as with a data model or user numbers or the type of database distribution. So lots are available here, lots of choices that we have to go through. The most popular data model that's currently in use is the relational database model, or the relational data model. Some of the ones I mentioned earlier, such as Oracle, MySQL, SQL Server, this software is going to support that type of database model. We have other traditional models such as the hierarchy model, but the relational model is the most current one. There have been other options such as object-oriented data models. They were introduced, and that's where your information is going to be represented in the form of objects. So there are different ones that you will come across in your studies. In a different classification, we have it can be based on the number of users. And your database management system can be classified this way based on the number of users that database is going to support. It can either be a single user database system, such as with a Microsoft Access database, or you could have thousands of users who need to use the system simultaneously. This is what's known as a multi-user database system. It's going to support lots of users concurrently. This is the model that you will find that most people in an enterprise, this is one of those areas that you're going to come across all the time where you can't just have a database such as, let's go with IMDb, the Internet Movie Database. Lots of people want to access information from that website. We all need to be able to access it when we want and not have to wait for the person who's on there to log off so that we can get on there. You could also have a classification based on database distribution. And there's 4 main distributions for this that we can use to classify our database management system. We have centralized systems, and with these systems, these databases are going to be stored on-premise at a single site used by several other systems. We also have a distributed database system, and within this we have 2 other categories, the homogeneous and heterogeneous. In a distributed database system, the actual database and the database management system software are distributed from various sites that are going to be connected through some type of computer network. Whether it's connected to physically or if it's connected through the internet, they are connected through various sites. The homogeneous distributed database systems use the same DBMS software from multiple sites. We're going to exchange between those sites, and it's going to be handled very easily. With the heterogeneous distributed database system, different sites might use different database management system software. So you can see where that might be a little difficult, but the distributed database system is going to allow it. Just note there's some additional common software that's going to be used to support the exchanging of that data between these sites that are using different database management software. I know that's a lot to take in, but just know there are different management system classifications based on how that database is used. Now, some other terms that are really big in the database world is a data warehouse. With data warehouse, this is where we start talking and getting close to talking about big data. The data warehouse is a system that's used for reporting and analyzing our data as part of a BI system or business intelligence system. And as we accumulate all of this massive data and it gets stored from a wide range of sources, we take that information to help make and guide our business decisions. So this is really related to big data, because big data is just that. It's all this data that's out there that we get from all these different sources, such as phones and even like our vehicles or traffic lights, parking meters, and then we take that to make decisions. And when I say parking meters, if we see that a lot of parking meters are not being used, then maybe as a community, we need to see why that part of town is struggling for businesses. Because if people aren't going there and we're recording that because of the pay that's going into those parking meters, then there's not a lot of flow or activity. Or maybe there's a lot of activity in areas where there's not enough parking, then we need to know, oh, maybe there's something going on there, and we need to see how we can incorporate that into areas that aren't so populated and busy. We want to make sure that our foot traffic is high in our communities to help our small businesses and to keep the popularity up and tourism coming into your community. Just a right off the top of my head example of big data. And we store all this data. As an example, Amazon works with big data. We're talking exabytes of data that they need to filter out. And that information helps with what products to push or to offer. So when it comes to this massive big data that's stored in these data warehouses, we don't have the ability to have the luxury of organized structured data. And that's where we get into some unstructured data and work with NoSQL databases. This is going to be another way of making use of our raw data to make useful information to help with our forward-thinking decisions. And real-time databases are just that. The information that's in them is up to date and it's getting populated. We can extract information from that, and it's current data. Now, I talked about most things. Here are a couple areas that you at least need to be familiar with. And that's some of the database access components for Microsoft Data Access Components, or MDAC. And this MDAC is really just a framework from Microsoft that makes it possible for us to connect and communicate with a database. It doesn't do us a lot of good to have a database if we can't connect with it and get that useful information created. And with this system or this framework, there are certain components that must be there. We have the ODBC, or Open Database Connectivity. We have OLEDB, Auto, or ActiveX data objects. Our MDAC is also going to install several data providers that you can use to have open a communication to a specific data source, such as an Access database. So your MDAC is going to have all these components, and it's going to install different data providers that allow you to connect to different data sources. At the top of the list here with ODBC, this is a native interface that exists, and it's accessed through a programming language that can make calls to the native library. And that interface is defined as a DLL, or a dynamic link library. And we're going to need a separate module or driver for each of our database that we're going to be accessing. Now the next one on the list there, which I actually misspelled, it's OLEDB. That's going to allow our Microsoft Data Access Components access to the different types of data stores in a uniform manner. Microsoft's been using this technology to separate the application from the data store that it needs to access. So just be familiarized with the term OLEDB. ADO, or Active Data Objects, this is a high-level programming interface to the OLEDB. It's going to use a hierarchical object model to allow applications to be able to create, retrieve, update, as well as delete data from sources that are supported by the OLEDB. And this ADO, it's going to consist of a series of different hierarchical COM-based or communication-based objects and collections. Really not going to go too in-depth in that. Just know that these are the components of the MDAC. I know that's a lot of information, a lot of different little pieces we talked about, but it's just to give you a familiarity of some of the terms we use for database design and a little bit about data, both structured and unstructured, and a little bit about how we take that data and make it into useful information. Having a lot of raw data doesn't do us much good. So whether we have an SQL-based system that we can manipulate data, add data, change data, and make sense of that raw data, or we're using a lot of big data and we're using no SQL type software to be able to make sense of the data, all data needs to be able to be useful or it's useless. Well, I hope some of this information was helpful to you. Thank you for following along in this video and have a great day.